Okay, here we go. We're talking about 4.2 today. I'm doing this out of order on purpose because this is an easy start. Okay, so I'm trying to do the things that are easiest in chapter 4. Since each section is an application, they don't feed off of each other. Everything is feeding off of taking derivatives, critical values, that type of thing, graphs, right? So I can do them in any order, so I do them in the order that's easiest. Okay, so 4.2 is absolute min and max. And we're just simply talking about the height, right? We're talking about, the shape of a mountain. Where is the absolute highest point or the absolute lowest point, right? So what is the absolute highest point on the Earth? I think it's Everest. There's some debate about it. And then Mount Everest. And then the lowest point is what's the trench called? The trench in the ocean that's deeper than Everest.
Dead Sea?
No.
Mariana's Trench.
Mariana Trench, right. So absolute min and max. So what we need for an absolute min and max is we need a continuous function and a closed interval. And if that's the case, we have everything we need to find the absolute highest point on the graph and the absolute lowest point. So if f of x is continuous on a b, closed interval, right, including the endpoints, yes, you with me there? Then f of x has a highest value and a lowest value called the absolute max and absolute min, right? Absolute max and min. And it will be found at, remember when I said wordy? It's wordy. It's a wordy chapter. The absolute max and min will be found at f of a, or f of b, or f of c, where c is a critical value of f prime of x. Let's remind ourselves what a critical value is. Critical value is when the right, c is a critical value of f prime of x when f prime of c equals 0, or f prime of c does not exist. What does that mean in even simpler terms? When the numerator of the derivative is 0 is when the derivative is 0. When the denominator of the derivative is 0 is when the derivative does not exist. So we're just looking for numerator equal to 0, denominator equal to 0, which is why I've been stressing this single fraction completely factored, right? Because it's easy to find the zeros when the numerator is completely factored. It's easy to find the zeros of the denominator if it's completely factored, right? So that's why I've been pushing that. We kind of let that rule go a little bit when we start doing antiderivatives. So for Calc 2, we're not as focused on making a pretty answer, which is nice. It makes it a little bit easier. That you don't have to do as much algebra, but for now we need to get the algebra perfect. Okay. Who's missing today? 3, 6, 9, 12, 15, 16. 4 students missing.
I think this rule makes most sense if you use an example with like a simple graph.
I'm gonna do it. Thank you. Thanks. Thanks, Teach. You got it.
No problem.
So what's interesting is if I remove my I can't think of the word. Why am I not thinking right today? If I remove my restrictions of continuity or closed interval, it's easy to see that I can't get a max or a min. Okay, but let's do one where I definitely do get a max or a min, right? So let's just look at a quick sketch. This is me just making this up. So I'm going from 0 kind of to 3. And there's my function, right? F is continuous, clearly, right? On 0, 3. And it's pretty clear that I see the minimum at 0, 0. So the min height is 0, right? I'm on the ground, right? And the max height is what? 2, 2. The ballerina point. The 2, 2. So, so the maximum point is here, right? And it's pretty obvious. Yes, it's the top of the mountain. Yes. So the max height is 2. And it's the y value that I'm talking about, by the way. It was a coincidence that both x and y were the same in this, right? It's the height we're talking about, the output. No, where is the max happening at? Is it at the endpoints, like I said it would be? Is it f of a or f of b? No.
It's at a critical value of f prime of x where it doesn't exist.
Exactly. The slope doesn't exist at that point. We got that cusp, right? So the slopes are different left and right. And, right. Nice. It's pretty obvious if I take out continuity, right? If I take out my continuity here, so at 2, 2, I remove that point, right? I know I never get a max. I can get as close as I can from either side to that top part, but I'll get to 1.9, 1.99. I'll never get to 2 if I remove the continuity piece of it. Of course, anytime I remove the continuity piece, then there's definitely a problem with the closed interval, right? It doesn't matter that the interval's closed. I can't use 2 there, right? So, but your friend is going to be the graph, right? So you're going to really stress using the graph. Every one of these problems on the Chapter 4 test, you'll know you got right. The trick is, if you put the right instructions on your formula sheet, right? The trick is, if you know you got it wrong, not to freak out, right? That's the trick. So if you do everything the way I'm going to teach you to do it, you'll know you have it right. And if there's some kind of mistake, the thing is, you practice enough so that you make the mistakes at home, when you're doing homework, not when you're doing the test. So that if you've realized that you've probably got your derivative wrong, right? Then you got to just stay calm. You can look for your mistake. It's usually better just to start a brand new page, in my experience, because I've gone through this. Okay. All right, I've got a nice step-by-step here for this section, and I will for every problem we do in Chapter 4. It's very calculated. It's very algorithm-oriented, right? There's a first step. There's a second step. So you're probably including those on your formula sheets, okay? So our step-by-step here. Is I want to graph f of x, right, on the closed interval if I can. I don't have to. There's a nice way to do that on the calculator. Just Google it. Graphing a piecewise function on the TI-83, 84, right? Find f of a and f of b. Find the heights at the endpoints, right? Find f prime of x. Find the derivative. This is nothing new so far. I mean, that's why I like to start with this one, because it's really easy. What we do Monday's easy as well, but it's just long. It's just annoying. find the critical values of f prime of x such that C belongs to the open interval from A to B. Okay, I got some notation there, so make sure you're okay with that. I want to find the critical values of f of x such that the critical values are in the open interval. Why? Once I find the heights at the endpoints, if the endpoints become critical values, I still know the height, right? I don't need to know the height again, okay? So I want the critical values that are inside of the interval. Find f of c, right? Update the graph, probably putting the points on. Putting the points on the 83 is not so easy, 83 or 84, but it can be done. And if you practice it enough, it'll be quick. You need the stat menu in the calculator. And then finally make a conclusion. So f of a equals -7 is the minimum. F of c is 32. That's your maximum, etc., etc. Right? Nice. Let's do one. Okay, ready? Let me know if you need a moment here to get all of this written down. I see Pedro's still writing, or
I finished.
okay, making sure. I think Markins is still writing.
Yeah, I'm finished.
Okay, nice.
Thank you.
Nice, no problem. I'm not in a rush, okay? I won't be in a rush in Calc 2 either. I do think I'm going to have you prepared for Calc 2 with any teacher. So you feel free. Like for me, I was working when I was a student, so I had to pick times for my classes based on my work schedule. I had no choice of teacher. So, and I think that was good for me because when I went to university, I had some pretty bad teachers. So the fact that I kind of had a variety of teachers in my community college was helpful. I don't think I had any repeat teachers at all. So, but anyway, I'm preparing you for even the most demanding Calc 2 teacher, which could be me, but if there's anyone else as demanding, you're ready for them, okay?
Yeah, and the second side, is it a plus sign?
So in where this line?
The second, no, the second.
And it's an and. It's an and. Yeah, ampersand. And find f of a and f of b. Find the heights at the endpoints.
Thank you.
Yes. All right. Let's do one of my favorite. Let's do f of x equals x square roots of 5 minus x from what? Let's say from 1 to 5. It's kind of nice. So as you get better at this, you'll be able to do this graph. In fact, one of the applications that I'm supposed to do with you is graphing, but I don't, just to save a little time, because we have the access to the calculator. But eventually, after chapter 4, you'll be able to graph everything without a calculator, which is kind of nice. But right now, we have it, so let's use it. Y equals x square roots of, what did I do, 5 minus x?
Yes.
And I want to restrict it from 0, so I'm using the curly bracket, 0 And there's a little menu down here at the bottom. Less than or equal to x, less than or equal to, oh, I said 1 to 5, right? Sorry. So I'll just change that 0 to a 1. It's very similar on your calculator, the notation to get that restriction of the domain. So there it is. You can clearly see the low point at 5, right, when x is 5, and you can see the high point, it looks like when x is 3 point something, right? So, so pretty easy, right? In fact, Desmos gives you the high point, right? There it is, 4 point something, and the low point is 0, right? Pretty obvious. How we doing? It's easy, right? Easy. Nice to have an easy section every now and then, really, honestly. So let's get started on our checklist. Oh, I did already. I graphed it, right? I probably, and I'm going to amend the graph as I go, right? I think at my second to last step, I said update the graph, but I'll do it as I go. So I want to find the endpoints first. So f of 1 is 1 times square root of 5 minus 1. That's 1 times 4, square root of 4. So 2, right? So I know 2 is a possible min or max. If I couldn't look at the graph, I wouldn't know. I would just know, okay, I got a height of 2. Let's see what other heights I have, right? F of 5 is 0, right? 5 times square root of 5 minus 5. So 5 square roots of 0, so that's 0. So I know now 2 can't be my min, right? 2 can't be my min. It's higher than the 0. So 0 could be the min. 2 could be the max. But I know the answer already. I love it, right? I love knowing the answer before I get to the end. It's kind of nice. It's like reading the last page of the book first. All right, derivative, right? How are we doing here? You're not copying me on this. You're doing your derivative yourself, right? So I'm going to use a product rule. I've got an x of 1, the square root of 5 minus x, a negative 1 over 2 square roots of 5 minus x. Let me know if anyone got there. Not copying me.
Yes, sir.
Yes.
So, this question, like, what is basically, like, what are we supposed to do? What's like the answer?
Where's the highest point of the graph? Where's the lowest point of the graph? If you think of this as profit in your, let's say you're making some product, and you have your input-output graph, right, that your accountant is creating for you. You can see where your profit is at a maximum, and then you're building your whole company to work at that production rate, right? We can see, right, where a heart rate is minimized at a certain amount of drug, right? Let's say it's someone with hypertension or something like that. We can look at the analysis of how the heart will perform at a certain number of cc's of this drug, right? And then we know we want to minimize, right, that heart rate, or at least get it to the place where it's good for the human, right? So that idea. And again, we're looking at graphs. We're looking at the high point and the low point.
So what we're doing right now is how to do it like without a graph, because
Correct.
do that.
Correct.
Okay.
Correct.
Okay.
Yes. But why not cheat if I can, right?
Yeah.
If I know I'm working, why not buy those sneakers now. I know I'm going to get paid Friday. I have to walk to work anyway, so. Anybody get there? Noah, thank you. Johan, yes. Markins? Nice.
Yes.
Nice. Chris, you alive?
Yeah, I got that.
Nice.
Yeah, this makes sense so far.
Good. I like that. I like when things are easy. So, I want to find my critical values, right? That's my next thing on my list. I want to set the numerator. So, f prime of x equals 0 implies the numerator is 0, right? So that means what? X is 2.5. And notice that belongs in my open interval, so that's good. 2.5 is between 1 and 5, right? And then f prime of x does not exist implies that 2 square roots of 5 minus x equals 0. So the downstairs equals 0, implies x equals 5. But I don't care about that because it does not belong to the open 1, 5. It's the endpoint. I already know the height at the endpoint. I don't need to think about that critical value again because I know the height at that endpoint, right? What's happening on the graph at that endpoint is I get a vertical. Remember, when the derivative does not exist, I get a vertical tangent line, right? When the derivative is 0, I get a horizontal tangent line. So I can see both of those on the graph, right? You with me? Anybody with me there?
Yeah, can you go over it again?
Yeah, when I get a critical value that gives me a 0, I see a horizontal tangent line. I see the top of a hill or the bottom of a valley. When I get a critical value that gives me a does not exist, I get a vertical tangent line, right? So you can see here, if I write x equals 5, I get a vertical tangent line on my graph at 5. Okay, I found my...
can you go over the equation again? I need to print first the equation.
The derivative.
No, the last one that you just did.
Oh, I just solved this for 0, right? It's obvious, 5.
Yeah, I get it.
Yeah.
Sorry.
So I know my critical value now, right? I actually like 5/2 better than 2.5, but because I want to kind of get a nice, pretty exact answer. So I have to find f of 5/2, right? So that's 5/2 times the square root of 5 minus 5/2. So that's 5/2 times, what is that, 10/2? Yep. Right? 10/2 minus 5/2 is 5/2.
Yes.
Yeah. So I mean,
it should be negative 5/2, right?
This is 10/2, right? 10/2 minus 5/2 is
5.
positive
Oh,
5/2.
the first,
Yeah.
not the second minus the first.
Yeah, exactly. Okay. So I think I want to make this look a little bit prettier. I don't really know how I can, but it looks like square root of what, 125 over 8. I certainly could get a decimal for that, but I like everything as exact answers. I mean, this is certainly fine. I'm just trying to write it as short as I can.
The one denominator is the part that goes the furthest.
Yeah, I'm okay with either answer there. But I want to put that in anyway. So let's go to my graph. Right, I had 3 points. I had 1, 2. I had 5, 0. I had 5/2, comma 5/2 square root of 5/2. Oh, I made a mistake, didn't I? Where did I make my mistake? See, that's nice. Did I make a mistake? Where did I make a mistake? Did anyone get the same derivative as me? Oh, you didn't correct me.
Is it?
I need a
Is
two-
it in
I
the
need a-
step going?
I need a 2 here.
Yeah, because you raised
Yeah.
square root of 5 minus
Yeah.
x into the right
How
side.
come you
and
didn't correct me?
I was on the verge of saying something, but I wasn't sure of my own work.
My critical value is 10/3. Sorry. See, but that's good. That's good. I made a mistake. Maybe I did it on purpose. No. 10/3 makes more sense to my picture. Anyway, right? 3 1/3. So what is this? 15/3. So 10/3 times rad 5/3. Sorry about that. I was asking, did anyone get the same derivative as me? Damn it. 10/3. And then what did I have here? 10/3 and what did I have inside? 5/3, yeah. There it is. That's the one. Look at that. Made a mistake. Knew I was wrong because I looked at the graph, right? So we're going to really do well on this test. Okay. This test is pretty damn short. I mean, I'm going to try and keep it 7 problems, but it's hard for me to make it 7 problems. I'd rather do 4 problems or 5 problems. It's a lot of writing, you'll see. Pretty easy, huh? And nice to know that I know for sure I got it right. Right? I love that piece.
For 1 second, can we go back to the derivative?
Mm-hmm.
Just a little bit.
So
Okay.
let me show the step.
Okay, yeah.
Let me show the step I skipped. I had to get an LCD here. I already know my denominator should be 2 square roots of 5 minus x. So I need to multiply this by 2 square roots of 5 minus x over itself. And that's the piece I missed. I missed the 2. I didn't use the 2 in my LCD. And so then you can see clearly I get the same denominator, right? And then here I get 2 times, right, that inside of the radical. Did anyone have the correct derivative, but it was different than mine and didn't say anything? Did anyone have the correct derivative? No one had the correct derivative at all? Oh my God, we're in trouble. Who taught you Calc 1? Well, guess what? That's about it. We're going to do a couple more problems. Where's the problem that's going to give you the most difficulty? What kind of function?
Trig. Well, no, not necessarily. Actually, it's going to be easier in trig.
For a lot of you, it's going to be trig. And so
if it's a simple trig, then it's perfectly fine. But then the tricky trig, and then turning it into a derivative is a little bit harder. But because it's on an interval, it's like max min is kind of simple.
So do you think Robert will put a trig problem on your test?
You're muted.
Thank you. Do you think Robert will put a trig problem on your test?
Yes.
Yes, he will. Why? Because some of you are having trouble with it. Some of you skipped trig. I don't know how. Or why you would have wanted to skip trig and torture yourself in Calc 1 and Calc 2 and for the rest of your mathematical career. So you better, yes.
What did you get 10 over 3?
I did this piece over, right? I did 10 minus 3x equals 0. So 10 equals 3x. So x equals 10 over 3.
Okay.
Yeah, so to find the critical value, right, set your numerator equal to 0, set your denominator equal to 0.
And the 5 over 2 is not part of it.
Correct. That was my mistake.
Okay.
Yeah, this whole line is gone. Yeah, thank you. Let's do 53. We're going to find the absolute. This is from the textbook. So this is 4.2, number 53, with some trig. So f of x is equal to 2 times the cos of x plus the sine of 2x on 0 to pi over 2. So I want to get a graph of it. Oh, Tali's not here. She just wrote me an email. I like if you don't come to class, you send me an email, please. So let's graph this. 2 sine x plus sine 2x on 0 to pi over 2. Uh, 2 cos x, plus sine 2x from 0 to pi over 2. Nice. Oh, pretty simple, right? Clearly, pi over 2 will get me my low point of 0, and it looks like my derivative will get me the high point, right? It's almost the same type of problem as we just had, but so what? Nothing wrong with that, right? Good. So what's first?
Find f of d.
Mm-hmm. So at f of 0, I get a height of 2. At f of pi over 2, looks like I get 0. Yep. So I certainly can go and update my graph there. Those are pretty obvious from the graph, so I won't bother in this case. Right, I can look at the graph and see that those points are true, right? I see 0, 2, and I see pi over 2, 0. So I don't really need to update the graph there. I know I'm right, right? But I need to find the derivative. Anybody get the same derivative as me? Hey, there's Udi. Udi's got his camera on. Nice, thank you.
2 cos. Oh, I guess it's because the interior.
Yeah, sine of 2x, derivative of the outside is cos, derivative of the inside is 2. So, right, cos of 2x times
Yeah.
another 2, yeah. This one I got to do a little bit of work on to get the 0. So I clearly know that if f prime of x equals 0, did anybody get the same? Anybody get the same derivative? Thank you, Noel.
I followed along on that one.
Don't do that. Upsoon. Do it yourself. Question, Upsoon?
Yeah, when I graphed it on the calculator, I put the, zoom, setting, so it's for trig.
Yeah.
And when I did that, it didn't end up being pi over 2, 0, but then when I got rid of the trig, it ended up being, there was a point in pi over 2, 0.
I'd have to look at it to know what possibly went wrong there.
But it should have been on pi over 2, 0.
Yeah. So,
Okay.
but look up the piecewise piece for your calculator so that you can restrict, so you can only graph that one little piece of it, and then zoom trig again, and it should be fine. Okay. So this one takes a little bit of work here, but obviously I'm going to say that minus 2 sine x plus 2 cos x, cos of 2x equals 0, right? And I'm going to use my trig identity here for cos of 2x. Well, I can divide by 2 first, right? So I get sine x minus cos of 2x is 0. I divide it by negative 2. And then what's my identity for cos of 2x? There's 3 of them. Fine, I'll look it up. No, I don't have my...
I'm pulling it up.
I don't have my formula sheet. Damn it. I want to say it's 1 minus 2 sine squared x. Someone to help me there. Anybody have their trig formula?
Crap, I don't have that one down.
Who's got the formula sheet there? Please
One of
verify.
them. Also, 2 cosine squared x minus 1.
Yes. So I got the right one. How do I know I got the right one? Because I've got a sign that I can't get rid of, so I want to turn everything into signs, right? So what do I get here? I get sine x minus 1 plus 2 sine squared x equals 0. And it looks like I have a quadratic. 2 sine squared x plus sine x minus 1 equals 0. So I've got a quadratic here, right? Please solve this without copying me. I know that sine x is minus b plus or minus square root of b squared minus 4 times a times c. Oh, b squared is 1. Sorry. So I get a critical value of pi over 6. Anyone get the same?
Yeah, I got the same.
Nice. Look at all that trig. Oh, yeah.
Yeah, it's a lot.
Yep. Gotta know it. Never get through Calc 2. I doubt we'll get through Calc 1 without it. I'm talking to everyone here. So if you don't know your trig, get on it.
Please.
I'm sorry?
Can you zoom out for me, please?
Yep. Yeah, but I don't want you copying this. I want you doing it yourself. Don't copy it.
Yeah.
Do it yourself. You should be able to do this. This is
So the main strategy that we went with was making it the same trig formula, then just going straight to quadratic formula.
yeah. Well, we did thousands of these in pre-calc class. In our pre-calc class, we did 1,000 of these trig equations. So you've practiced them. You know what to do. So trust your gut. Practice enough problems that and that's what I did. I did every problem because I was worried about getting a problem that I had never seen and done before. Of course, I still got one on the test, but I had practiced so much that I was able to improvise, right? And come up with a process to solve things. It does take that amount of work. It's like playing a song. You're going to work for years and years before you can even play the song, but then it's going to sound chunky, and you got to get it some soul, right? You got to put real feeling in it, and that takes hours and hours of being one with the music. You have to do that in all of your life. If you're going to have a real relationship with something or someone or an activity, a sport, whatever, you've got to get in deep with it, okay? And that means time. All right, our next step is f of pi over 6, right? Once I found my critical value, I'd have to plug that critical value into the function. So what did I have? 2 times the cos of pi over 6 plus sine of 2 times pi over 6. So that's 2 times cos of pi over 6 is rad 3 over 2. And sine of pi over 3 is, don't tell me. Oh, it's rad 3 over 2, right? Yeah. So I get 3 rad 3 over 2. And that's obviously my max.
This time you're sure it's not 2 times 3.
Are you
when you raise their LCD.
Are you copying me, or are you doing the work yourself?
No. I'm just.
No, don't just look. Do.
Okay. Yeah.
What did Yoda say to Skywalker? Don't try. Do. You can't try something. You can either do it or you can't. So I want to double check this, right? I want to double check this. So I'm going to go to my graph. And I'm going to plug in that 1 point. What did it say? Pi over 6. Comma. Oops. What did I do? Pi over 6. Comma. 3 rad 3 over 2, right? 3 square root of 3 all over 2. Yes! We are the champions. It's fun to get things right. Don't you love math for that? Isn't that the one little thing about math that's enjoyable? It's like, oh yeah, I got it. I got it. I might
Having a page full of complicated work and having the answer right at the end is always good.
right? So do every trig one in the book, right? I think there's only one trig one on WebAssign. One or two, I think.
My question, Professor, why do you say 3 pi over 2 doesn't exist?
I didn't say that. I said 3 pi over 2 does not belong to my open interval.
Yeah.
Remember,
doesn't belong.
my restriction on my curve, right, was what? From 0 to pi over 2. So 3 pi over 2 is way over here. So it can't be a critical value. I don't care about it. It is a critical value, but I don't care about it. I only care about the one that's in the interval that I'm working with. Yeah, there's some good ones. I like all of the problems from 41 to 54. So that's where the homework will come from. So certainly you could start working on those. It looks like there's 1, 2, 3 trigs in there. So that's good. I probably will assign, I'm just thinking, what would I assign? 47, 49, 51. It's probably what I would assign. And then I'd put a trig one on the test to see if you did the extra work yourself, right? I'll put that homework up next week.
Oh, so those problems that you're looking at right this second aren't trig in the book?
Correct.
Okay. Where would we find some trig ones?
There's 3 trig ones in there.
Okay, so
yeah.
You just said them.
And then look at all my old tests once I post them. I didn't post them yet. This weekend I'll do it. Well, I'm fine with just the 2 examples today. If you want me to do another one, I will. If you want to go have breakfast, feel free. Have a great weekend. Work on the project. I won't be around Friday, but you certainly could send me emails. I would probably be able to answer Friday emails after 6 p.m. Okay, but I certainly will answer emails over the weekend. Monday, of course, you could ask me questions on the project. Remember, part E is the tricky one. I want everything done as algebra. In fact, let me give you a quick hint on part E right now. Okay. To get an error, right? To get an error, the error formula in general, and you know this from bio probably, is an absolute value of actual minus experimental
I did that 2 years ago in chem.
Yeah. So actual, right, and then as a percent, right? So percent error. So actual minus experimental, we always want a positive, so we put the absolute value on it, divided by the actual, and it will give me the error, right? So for us, we're going to have an initial error when we're doing Newton's method, and then we're going to have the next error, right? So remember how I guessed my first x, and then I solved to get the x next. So same thing, I'm going to have an error, an initial error, and then I'm going to have a next error, and I'm trying to show that the next error is the initial error squared. Which is interesting in this particular problem. This is again the problem that we're trying to find the reciprocal of pi. Okay, so we're trying to show that the next error is the initial error squared. Now, if you think about that,
so would it mean that infinite amount of errors? It's the initial error to the highest power. It'd get smaller and smaller.
Exactly. When the error is less than 1, exactly. When the error is really close to 0, and then I square it, it's going to get even closer to 0. And that's
it'll never reach 0.
Well, yes, it will. Infinite.
Oh.
Yeah.
Okay, yeah.
But remember, for us, we're setting our calculator to 2 decimal places or 4 decimal places or 9 decimal places, and eventually we'll get to the 9 decimal places. Of course, decimal place 3,217 is still not right yet, right?
Yeah.
But we don't care about it, right? So we need 2 formulas here. We need the initial error. And the next error. We need 2 formulas in part E. So the initial error, remember we're trying to find the reciprocal of pi, but I think I think we're using 1 over b. I think. So our actual is 1 over b, and our experimental is our guess. So there's the initial error. Right? This is my initial guess. You with me? Is everybody okay? I know I probably let you down a little bit. I said go have breakfast, and then I started talking all this nerd crap. So there's my initial error. And make it look pretty, right? Obviously it doesn't look pretty. The next error almost looks exactly the same, but what do I want to put in for x? Who's got the idea? What do I put in for x?
X next?
Yes! Someone's got the big brain on today. And so that is x minus f of x over f prime of x. Right? So once you have those 2 pieces, you should be able to show that this is true. Once you have those 2 pieces, your initial error and your next error, you should be able to show algebraically. No numbers. Don't put pi in there anywhere. Right? Don't put any decimals in there. Don't do the calculations on this. Right? You should be able to show me algebraically that these 2 are equal. And it means do some algebra. I think it's distributing or factoring or both or something. That's part E. That's the trickiest part of the project. Okay? Anybody working on it in groups? Anybody have a group that you're doing with? Nice, Max. Anybody else? Marcus?
Yeah,
yes?
I think there's
we're bringing it right now.
Good. Caitlin?
There's a group of 5 right now.
Yeah, but it
we
can
have
be
a group
maximum of 3. The groups on the
chat.
project
So we'll
can be
probably split up the work.
The group work has to be maximum of 3 because part F has got 3 questions and each of you do 1 of them if you're in a group of 3. Caitlin, question?
No, sorry.
No
I'm
problem.
just saying I was in a group, but
No problem. Oh, cool. Thank you. Good. I like that. Again, your current grade has this calculated in as 100. So if you decide you don't want to do it, just take your current average, which is in Blackboard right now, and subtract 10 from it, right? And then that's your new grade. I've had students with A's just take a B because they don't feel like doing the project. It's fine. I don't care. I think it's really valuable if you work with someone else. But some of us don't like other humans. So, I'm trying to learn to like humans. It's not easy, but. All right, I'm done today. All right, have a great weekend. I'll see you on Monday. I will send out an announcement Thursday night.
Is there a way to make breakout rooms in the empty lobby?
Yeah. I mean,
because we'll be using it Friday probably.
If you're the host, so whoever comes in first is automatically named a host, and that person can create breakout rooms and assign them.
Okay.
Do you want? Why don't I leave and then see if whoever comes in first gets to be the host. Okay, so they'll be able to create breakout rooms. They can also name someone else as a host. Okay, so if they're having trouble, whoever came in first can name another person a host, and then so for example, let me name you a host right now, Jesse, and and then let's see if you have control. And soon I'll get 1 second. I'll see if. So I've now made you a co-host. See if you have the option there in that bottom bar. I'm going to stop my share. There should be a place for you where it says more or even breakout rooms at the bottom of your screen now.
Yeah.
So see if can you see the breakout room one and can go in there and see if you could create. Don't do it, but just see if if it's live.
I would be able to. Yeah.
Yeah. Okay.
I
Cool.
Click on somebody and say
exactly, and then you can assign people. So you could push your group of 3 into one room and another group of 3 in another room, and
that's probably what we'll
pretty
end up
straight.
doing.
Yeah, it's pretty straightforward. Okay.
That way we stay, working in small groups. That's more important as well.
Okay, Afsun, what's up? Question?
Yes, so I know you won't be here Friday, but your office hours from 3 to 4 tomorrow are still valid, right?
Yes, exactly. So, is it tomorrow?
I thought it was Thursdays. Is it not Thursdays?
Thursdays are on. No, Thursday is I'm on campus.
Oh, okay.
So it's today. It's today from 3 p.m. to 4 p.m.
Okay.
Are you coming by today?
I'll make it work. I have work right now, but I'll figure it out.
I can move it a little later.
I have to go over.
Send me an email and I'll make it later so you don't have to leave work early.
I'll see. Okay, I will if that ends up being necessary.
Good.
Thank you.
Yep.
Professor.
Yes.
See you.
There you go.
Oh, no, nothing.
Yep.
Just
Yep, absolutely. See you on Monday.
Bye.
All right. See you Monday.
Bye, everyone.
Part A and B are just yes, correct, Noah. C is we're starting to apply it. Yes, I remember I did C. I did part C. Just want to make sure I'm understanding what's on the PDF. Yes, part A and B was me generating from the tangent line. How do I solve for that x-intercept, right? And then part B was how can I rename it so it's nice, right? And so I think they're asking you for x sub n's, and I just did x's and x next. So I don't care what you do there for part B, right? Any way you want to do it is fine with me. And then part C I did, so you're going to repeat that. Part D, you're going to do it again, but with a new function, right? Part E is here on my page, right? Well, the page I just had. I can share it again if you want a picture of it. And then part F is where it fails. And it's really nice to do that one graphically and numerically.
Thank you. I just wanted to make sure I was understanding anything.
Yeah, it's pretty super nerdy, right, when you read it?
Yeah, I just, because originally I was thinking, because I know you said that C is where we started, and I was assuming just by reading it, like, it was just like the, kind of like the theoretical,
Exactly.
how, yeah.
Exactly, yeah. Nice.
Yeah, thank you. I just wanted to clear that up.
Cool. Nice. Nahom, what's up? You need me?
Yeah, Professor. So, for the second test, Professor, for the first question,
Yeah.
I think you minus marks because I found so using the L'Hopital's.
Yeah, let me look at it. Let me look at yours. Homework test, chapter 3 test. Nahom. Where are you? There you are. I'm looking at it. I can't. What did I take off? 4 points? Oh, or on.
Yeah, so you took 4 points off, and now I was using limits to find the derivative.
Oh yeah. No, my issue was. Where I circled on the first page, right? You got me. You should have just taken derivatives. I don't know why you're doing a limit. That's what I'm saying there. I want you to only use L'Hopital's rule. Don't do any limit work.
Oh, so no. So I did use L'Hopital's rule. I used the limit to find the derivative of one of the terms. Because I just didn't know it by heart.
Oh, I got you. I see it. Okay, you're right. I'll look at it again. I probably owe you points there. What else?
Yeah, that was it. Yeah,
okay, nice. You did great.
Yeah.
Right? You got an A in the class. You're going to get an A in the class. Just keep up the good work. Okay? All right, nice. See you later.